Hello students, welcome to the class. Today we are going to discuss exercise 6.2 of class 10th, chapter number 6. This is your repeated class. In this live class, I will consider your doubts. So if any doubt is there, you can ask. Let us see. This exercise is based upon basic proportionality theorem, BPT, and its converse. So let us remind what is BPT theorem. What is BPT theorem? Basic proportionality theorem. What is basic proportionality theorem? If a line is drawn parallel to one side of a triangle intersecting other two sides at two distant points, then other two sides are divided in the same ratio. If a line is drawn, parallel to one side of a triangle intersect other two sides at two distant points, then other two sides are in the same ratio. Let us see. This DE is parallel to BC, then AD by this DB equals to AE by EC. If a line is drawn parallel to one side of a triangle intersecting other two sides at two distant points, then other two sides are divided in the same ratio. That is AD by DB is equals to AE by EC. This is basic proportionality theorem. And what is its converse? Its converse is if other two sides are divided in the same ratio, then this DE will be parallel to BC. This is its converse. Let us start exercise. What is first question? In figure first and second, DE is parallel to BC. This DE is parallel to BC and DE is parallel to BC. In question number 1, find EC. This EC we have to find out and AD in second figure. Now, first part, as this DE is parallel to BC, then I can write this AD by DB equals to AE by EC. If a line is drawn parallel to in a triangle, if a line is drawn parallel to one side of a triangle, then it will divide other two sides in the same ratio. This states basic proportionality theorem. Why we are writing? Using BPT theorem. Basic proportionality theorem. Now this AD is given to us 1.5 centimeter and this DB is 3 centimeter. This AE is 1 centimeter and this EC we need to find out. Using cross multiplication, we can find out this EC. 1.5 centimeter into EC equals to 1 into 3. Now EC is equals to 3 centimeter by 1.5 centimeter. This will be centimeter square. This was in centimeter. So it will be 30 by 15 centimeter. 15 1 ja 15, 15 2 ja 30. 2 centimeter. This EC is 2 centimeter. Second part, what is second part? In this triangle ABC, this DE is parallel to BC. DE is parallel to BC and we have to find out the side AD. If DE is parallel to BC, then by basic proportionality theorem, I can write AD by DB equals to AE by EC. AD by DB is equals to AE by EC. Now, what is AD? AD we need to find out. Let us use next page. This AD we have to find out. AD by BD and their AE by EC. AE by EC. This AD we have to find out and BD is 7.2. AD by 7.2 centimeter equals to AE is 1.8 and it is 5.4 centimeter. EC is 5.4 centimeter. So using cross multiplication, find out this AD. 5.4 centimeter into AD equals to 1.5 centimeter into 7.2 centimeter. This AD is 1.5 centimeter into 7.2 centimeter by 5.4 centimeter. 1 centimeter to 1 centimeter cancel. Remove these decimals or you will write this is cancel 15 into 72 by 54 and for this decimal you will write 10 centimeter. Cancel with 9, 9 6 ja 54, 9 8 ja 72, then 3 2 ja 6, 3 5 ja 15, 2 1 ja 2, 2 4 ja 8, 4 5 ja 20 by 10 centimeter. That is, this AD is 2 centimeter. AD is 2 centimeter. Let us see next question. What is next question? E and F are points on the sides PQ and PR. E and F are points on the sides PQ and PR respectively of a triangle PQR. Draw a triangle PQR. This PQR. For each of the following cases, state whether EF is parallel to QR. We need to tell this PQR, this is EF. Whether EF will be parallel to QR. This we need to tell. Whether EF is parallel to QR. Now see, if a ratio of this PE by EQ is equals to PF by FR, if I will get PE by EQ equals to PF by FR. PE by EQ and PF by FR, if this ratio is equal, then this EF is parallel to QR. Otherwise, we will say no, this EF is not parallel to QR. Let us see. PE is 3.9. It is 3.9 centimeter and EQ is 3 centimeter. This EQ is 3 centimeter. PF is 3.6 centimeter and FR is 2.4 centimeter. Let us check ratio in triangle PQRS. This PE by EQ. If PF by FR. Let us check out this ratio. What is PE? It is 3.9 centimeter and EQ is 3 centimeter and PF is 3.6 centimeter by 2.4 centimeter. Now check out centimeter to centimeter cancel. Everywhere this decimal to decimal will be cancel. It will be 39 by 30 equals to 36 by 24. Cancel with 12. 12 2s are 24. 12 3s are 36. And it will be cancel with 3 first. 3 1s are 3. 3 3s are 9. And 3 1s are 3. 3 0s are 0. This is 13 by 10 and that is 3 by 2. This 13 by 10 is not equals to 3 by 2. That is, we can say this PE by EQ is not equals to PF by FR. Then we can say this PE, this EF is not parallel to QR. In first part, what we got, this EF is not parallel to PQR. You will write EF is not parallel to this QR. EF is not parallel to QR. In second part, what is second part? Draw a triangle PQR. This is PQR and this is EF. Let us write what are sides given to us. PE is 4. PE is 4 centimeter. QE 4.5. 4.5 centimeter. And PF 8, RF 9. And RF 9. Let us check out ratio. If this PE by EQ equals to PF by FR, then we can say this EF is parallel to QR. Let us check out this ratio. This PE is 4 centimeter and EQ is 4.5 centimeter. This PF is 8 centimeter and FR is 9 centimeter. Centimeter to centimeter cancel everywhere. Now this is 40 by 45 and 8 by 9. Let us cancel with the 5. 5 8 are 40 and 5 9 are 45. You will see 8 by 9 is equals to 8 by 9. Means this ratio is equal. If this ratio is equal, then this state that PEF, this EF is parallel to QR. EF is parallel to QR. This EF is parallel to QR because corresponding sides ratio is equal. This is 8 by 9 and 8 by 9. Let us do third part. What is third part? Draw triangle PQR. PQ is 1.28. This is PQR and this is EF. PQ is, let us check out statement. PQ 1.28 centimeter. PQ is 1.28 centimeter. PQ 1.28 centimeter. PR 2.56. PR 2.56 centimeter. More. This PE 0.18 centimeter and PE is this PE. Let me check what is this. This PF. This is PF is 0.36. PF is 0.36 centimeter. Now see, this PQ is 1.28 centimeter and PR is 2.56 centimeter and PE is 0.18 centimeter and PF is 0.36 centimeter. One corollary is also there of BPT theorem. We can write this PEF triangle is similar to this PQR. This PEF triangle is similar to PQR. Then what we can write? Corresponding sides ratio we can write PE by PQ equals to PF by PR. If this one ratio will be equal, then we can say this EF is parallel to QR. This is corollary of BPT theorem. And we can prove this using similarity theorem by proving these two triangles similar. Now, what is PE? PE is 0.18 centimeter and this PQ is 1.28 centimeter must be equals to this PF. What is PF? 0.36 centimeter by what is PR? This PR is 2.56 centimeter. Now see, decimal to decimal will be removed. There also decimal will be removed. Centimeter to centimeter cancel. Now you can write 18 by 128 equals to 36 by 256. Let us cancel. Let us cancel with 3. 3 6 18. This is not cancel with the 3. This is 18 by 128. 2 9 ja 18, 2 6 ja 12, 2 4 ja 8. Cancel. Cancel with 4. 4 9 ja 36. 4 6 ja 24. 4 4 ja 16. This is 9 by 64 and this also 9 by 64. We got this PE by PQ is equals to PF by PR. Then we can say this EF is parallel to QR. Now this ratio is equals, if this ratio is equal, then we can say this EF is parallel to QR. EF is parallel to QR. Now question number 2 is completed. Let us start next question. Question number 3 part. First, second, 3. This is second part already we have done. Now, okay, separately they made. Question number 3. What is question number 3? If LM question number 2 we have done. Now question number 3. Question number 3. Let us see what is question number 3 stating. If LM, this is LM, is parallel to CB and this LN is parallel to CD, then we need to prove AM by AB and AN by AD. Okay, let us see in triangle ACB. ACB. We know this LM is parallel to CB. This LM is parallel to CB. It is given to us. Then by BPT theorem, I can write their corresponding sides ratio will be equal. Corresponding sides ratio will be equal. Then I can write AM by, again see, you can check out there. This is A, B, C, and this is L, and this is M. This LM is parallel to this BC. Then you can write AL by BL equals to AM by MC. Corresponding sides ratio you can write equal. So you can write AM by MB equals to AL by this LC. AM by MB. Okay. AM by MB, AL by LC by BPT theorem. Say equation number 1. Now second, what is second? In triangle ADC, this time ADC triangle I will consider. In this triangle, this LN is parallel to CT. LN is parallel to CT. Now then corresponding sides ratio I can write AN by ND equals to AL by LC. This is also by BPT theorem. Equation number 2. This is equation number 2. From 1 and 2, this AL by LC and this also AL by LC. Means from equation number 1 and 2, both equations contain their right hand sides equal, then their left hand side must be equal. From 1 and 2, I can say from 1 and 2, AM by MB equals to AN by ND. AM by MB is equals to AN by ND. And what was to prove? This was same. AM by MB. Okay. AB. AM by AB and AN by AD. Let us see how we can prove. Proof not completed. We got AM by MB and AN by this ND. How we can prove that this corollary as a result we are using. Now see how this we are writing in this triangle A, B, C, C, and this is D, and you can say this is F. I can write AD by this AB and AF by AC. How we can write this? Let us do its proof. Take its reciprocal once. It will be MB by AM equals to ND by AN. Now adding 1 on both sides. Adding 1 on both sides. Add 1 on both sides. Then it will be MB plus AM by AM equals to this ND plus AN by AN. If you will see in figure, MD plus AN. Where is MD? MB. This is MB. MB. This is MB plus AM. I will get AB. In place of this, what I can write? AB. AB by AM as it is equals to ND plus AN. AN plus ND. I will get AD. There AD by AN as it is. AN as it is. Take its reciprocal. Take its reciprocal. When you will take its reciprocal, you will get AM by AB equals to AN by AD. This is same. What was we have to prove? Question number 3 is completed. Next question. What is next question? DE. This DE is parallel to AC. This DE is parallel to AC. Okay, and this DF is parallel to AE. DF is parallel to AE. Let us do it later on. First, we want to do in one triangle work. Prove that this BE by BF. Using this one information, I want to work in this triangle. Okay, in triangle, and then after that we will see what is to prove. In triangle ABC, ABC, this DE is parallel to AC. This DE is parallel to AC. Then corresponding sides ratio will be equal. I can write this BD by DA equals to BE by BEC. What we can write? BE, this BE by EC. AC. This is by basic proportionality theorem. Say equation number 1. Now, this DF is parallel to AE. Let us this time DF. Where is DF? This is DF is parallel to AE. Now I want to work in this triangle as in triangle ADE. This DF is parallel to AE. Then I can write this BD by DA equals to BF by FE. BF by FE. This is by BPT theorem. Say equation number 2. From equation number 1 and 2, what we can say? You can see BD by DA, BD by DA. Both equations contain their left hand side equal. So their left hand sides will be equal. Equate. It will be from 1 and 2. This BE by EC equals to BF by FE. And what was to prove? BE by EC, this BE by EC, BF by EF. Same. Hence, proved. So, using BPT, you can prove them easily. So, before doing this exercise, it is necessary that you must know about BPT and its converse. Question number 5. Let us do question number 5. This DE is parallel to OQ and DF is parallel to OR. Show that this EF is parallel to QR. Let us discuss one by one which line is parallel to given. Which one? This DE parallel to OQ. This is DE. DE is parallel to OQ. DE is parallel to OQ. So in triangle PQO, I will work as in triangle PQO. This EO is parallel to QO. This EO, sorry, this point is D point. This ED is parallel or D is parallel to OQ or QO. Now, if these two lines are parallel, ED is parallel to QO. So I can write this PE by EQ equals to PD by DO. This ratio will be equal by basic proportionality theorem. Would state if a line is drawn parallel to one side of a triangle intersecting other two sides at two distant points, then these other two sides are divided in the same ratio. So by BPT. So equation number 1. This is equation number 1. Now this DF is also parallel to QR. Let us see. This time DF, this is DF is parallel to OR. In triangle POR, this DF is parallel to OR. DF is parallel to OR. This DF is parallel to OR. So I can write this PD by DO, PF by EFR. So I can write this PF by FR equals to PD by DO. This is by BPT theorem. So equation number 2. From 1 and 2, you will see their right hand side is PD by DO. and this also right hand side PD by DO. So their left hand sides will be equal. What will be left hand side? From equation 1 and 2. This PE by EQ equals to PF by FR. Now check out this ratio in triangle PQR. This PE, what we are getting now? This PE by EQ and PF by FR. We are getting this PE by EQ and PF by FR. Then by converse of midpoint theorem, this EF is parallel to QR. This is by converse of BPT. By converse of BPT. This EF is parallel to QR. As corresponding sides are in the same ratio, then these lines will be parallel. This EF will be parallel to QR. Question number 5th is completed. Next question. What is next question? Next question is, okay, now I have seen your comment. It's Parmar. Then full form of BPT is basic proportionality theorem. As starting of this class, I have told you about BPT. What is BPT and its statement? So, where is problem? In which point? At which step is your problem? You can write. Let us again see this question. If this question you are not able to understand, this DE is parallel to in this PQR triangle, this DE is parallel to PQ. This DE is parallel to PQ. This ED you can say parallel to QO. And if these lines are parallel, then these other two sides will be divided in the same ratio. If you will work in triangle PQR, see, again I want to tell what is BPT theorem. Basic proportionality theorem. What is basic proportionality theorem? This is triangle ABC. If a line is drawn parallel to one side of a triangle, this is one, consider this one side. If this line is drawn parallel to BC, say it is E and F, and intersecting other two sides at two distinct points, then these other two sides are divided in the same ratio. Means if this EF is parallel to BC and this AE by EB equals to AF by FC. This is basic proportionality theorem. Now, based upon this theorem, we were doing our question. What is our question? This ED is parallel to QO, and then I can write this PE by EQ and PD by DO ratio equal. This is by BPT theorem. Consider equation number 1. In which triangle we were working? PQO. In PQO triangle, this ED is parallel to QO. Then PE by EQ is equals to PD by DO ratio. Equation number 1. In second triangle, you will see this time POR in this triangle. This DF is parallel to OR. DF is parallel to OR. Now, if these two sides are parallel in triangle POR, then I can write their corresponding sides ratio. This PF by FR equals to PD by DO. This by BPT theorem we have written. And you will see, compare this equation number 1 and 2, this right hand side PD by DU and right hand side PD by DU. Then their left hand sides will be equal. That is PE by EQ is equals to PA by FR. Now, if in triangle, in this triangle, you will see, in triangle PQR, if you are getting this EF is parallel to QR, then corresponding sides ratio will be equal. Then I can say PE by EQ. As I know from equation 1 and 2, I got this PE by EQ and PF by FR. Then by converse of BPT state that this EF will be parallel to QR. If corresponding sides ratio are equal, then these lines are parallel. This EF will be parallel to QR. Hope you have understood this question. Let us start our next question. Question number 6. What is question number 6? Read out statement. Question number 6. What is question number 6? A, B, C are points on OP. A, B, C. Let us write these points. These points are not visible. This point is P. This point is Q. This point is B, O, C, R. And this point is A. Now see. A, B, C are points on OP. This is OP and OQ, OR. These are ABC points on these sides respectively, such that AB is parallel to PQ. What is given? This AB is parallel to this PQ. AB is parallel to PQ and this AC is parallel to PR. This AC point, this is C point, is parallel to PR. Then show that this BC is parallel to, we need to show this BC is parallel to QR. This BC is parallel to QR. Now see, in triangle POQ, in this triangle I will work POQ, in this triangle. POQ. As this AB is parallel to PQ, AB is parallel to PQ, then if these are parallel, then corresponding sides ratio will be equal. This OA by PA I can write and OB by QB I can write. I can write OA by PA equals to this OB by this BQ. AB is parallel to PQ, then OA by this AP and OB by this QB ratio I can write by BPT theorem. By BPT theorem. Next is, say this is equation number 1. In triangle, one more information is given to us. This AB is parallel to QR. Now this AC is parallel to PR. As in triangle AOR, POR, in this triangle, POR. In triangle POR, this AC is parallel to PR. AC is parallel to PR. Then I can write this OA by this PA ratio equals to OC by CR. This OA by PA ratio and OC by CR ratio. This will be equal by basic proportionality theorem, by BPT theorem. Say equation number 1 and 2. Now observe equation number 1 and 2 carefully. This is OA by PA and there is also OA by PA. Their left hand sides are equal. Now their right hand sides will be equal. By comparing 1 and 2, what we will get from equation 1 and 2, this OB by QB equals to OC by CR. Now check out this ratio in your figure. OB by OQ. This OB by QB, OB by QB and OC by CR. This corresponding side